All right, so we want you to look at page 337, okay? And the reason that we're going to go over this is I'm a believer in this, okay? And I think you could ask the juniors, okay? When it comes to that periodic table, or even anything when it comes to even human anatomy and physiology. I like to say, if you know the content today, you're going to know it tomorrow, you're going to know it the next time, and it's quite possible that if you don't use something in a large or long amount of time, yeah, then you might forget it. But what I mean by that is I'm willing to bet that I can draw 3 of these things up, or you don't need to draw this, that some of you can still name at least one of these 3 polyatomic ions. Sulfate is one of them. Nitrate's another one. So you said sulfate, you said nitrate, and you were not that far off. What did you say? Oh, well, no. Okay, we'll give, it's actually carbonate. So I said one of the 3. You people came up with 2 of the 3. So you knew it back then, you know it now, you'll know it in the future. Okay? So we bring that up because on page 337, okay, even if you're just looking at that picture only and didn't read anything about it, what can you presume about that when you see that there's a molecule of DNA on the top and that RNA polymerase is that green circle going in that direction? What process can you tell me that is? Well, see, that's the entire process. We want to be a little more specific. You're not wrong. But what does it mean? What do you suppose is actually happening? That DNA is being read. What do we mean by that? So when we say read, that means it's like a scribe reading it. Okay? So on page 337, transcription. The first step of the central dogma. I think we've read this before because I don't like that term dogma, but that's what the author uses. Does this sound familiar? Okay. Oh boy, I think we had read some of that. Then the rest of the chapter, I totally forgot about that. It's just the idea of once I read dogma, I said, okay, that's probably not, we probably read that already. But then look at page 346 then. Okay? When there's a table there, it's table 3 on page 346. Okay? So what that table is showing is different types of mutations. And I think on Tuesday, didn't Mr. Wagner go over some of those mutations with you? Yeah. But he probably did not look at the book here, because I did not read or tell him to, or instruct him to do that. But when we talk about mutations, the first one says that's normal. The analogy sequence that we want it to read is the big fat cat ate the wet rat. So how many of you could say that really fast?
The big fat cat ate the wet rat.
Did you get it right?
I think I did.
I thought you missed a word.
No. What was it? The big fat cat ate the wet rat.
Oh, you did get them all. Big fat cat ate the wet rat. Okay. So when you're talking about the next one down, in other words, missense, that means a substitution can take place. And the example of that would be on Tuesday when Mr. Wagner was in here for myself. That's a substitution, taking the place for myself. So in that case, it's talking about the biz fat cat ate the wet rat. I mean, it's close, okay? But biz does not make any sense. It's supposed to be big, but it says biz, so that's a substitution. It doesn't make any sense, because who would say the biz fat cat ate the wet rat? Nobody would, okay? So then the next one down is nonsense, okay? Just says the big rat, okay? Then that's another form of a substitution. I mean, it doesn't make any point. It just says the big rat. Well, that's a sentence fragment. How many of you like English and using grammar? Okay? So the top one, normal, that is a complete sentence. When you look at the third one down where it says nonsense substitution, the big rat, that is a sentence fragment. So that does not make any sense. Okay? Then the next one down is what we call a deletion. Okay? And what it is showing is, okay, when you interpret that, this is what it's supposed to say. But this, oops, I'm getting a little ahead of myself. But this is what it's actually showing. Okay? In other words, it's taking the next word, okay, so I'm guessing that is big. It took that B, took the E out, and moved that over a space. So that is a deletion, and that's what it's trying to illustrate. I mean, you can read what it says, it's a deletion, but until you see what it's actually trying to illustrate, it probably doesn't make any sense. Okay? And then in insertion, okay? Well, then that's another type of frame shift where you're just inserting information. In this case, when you read that, what's the first letter that got inserted that doesn't make any sense? The Z. So that got inserted in there where it doesn't belong. Okay? So again, that is another type of mutation. Okay? And of course, the big fat cat ate the wet rat. A duplication. It said the fat twice. Okay? So how many of you can read that really fast?
The big fat cat ate the wet rat.
You know, it kind of sounds, that's pretty good. Actually, because I don't know if I could, I'll try. The big fat cat ate the wet rat. Oh, maybe with a little bit of practice. Okay? So, God, I hope I turned this on. Yes, I did. Okay. And then down below, it's just showing you all of the things that could happen. Now, those are just examples, okay? But the best one to see when we're talking about a mutation is what you see on page 347, okay? And that's an application that we talk about in the biochemistry class, okay? Is the idea behind hemoglobin, which means blood, okay? So hemoglobin is just the liquid part of blood. And then when we see the genetic code for that, okay, it has a box around glutamate and then valine. So glutamate is the normal DNA, or excuse me, the normal codon, but then valine, that would be a type of mutation. And when we see these mutations in action, okay, of course, this is normal. Nice red blood cell like that. And then this is abnormal. Okay? So again, these are both red blood cells. Do we possibly know what the function of red blood cells are? Yeah, they're going to carry oxygen. So, can you see there's two problems with this, okay? What is the first thing that would stand out in your mind? If these cells are to carry oxygen, what's the first thing that might pop in your mind? Why is someone going to be anemic? In other words, man, they don't do a whole lot, and all of a sudden, ah, dang, I'm tired. Well, you're close. Well, they got the mutation, but typically it does not hold as much oxygen, and if it can't, you just do something very light exercise, you're like, oh my gosh, I'm tired already. Okay? So that's probably the number one problem with that. But The next problem would be, what do you suppose the shape of blood vessels is looking down the blood vessel? Say that again. A tube. Okay. So here's our tube or blood vessel, just a cross section. So that's this marker. Then if we turn it sideways, okay, so we're taking this tube and turning it sideways, that red blood cell will fit inside this tube really easily. Okay, I shouldn't have made this as big, but you get the idea. We just wanted it to be circular. Okay, so what would a secondary problem be? This can't carry enough oxygen, but what might a secondary problem be of that sickle? Exactly. Okay, so I need to make that smaller. So now if we take that cross section here, could be such a thing that here's that cell trying to go down that tube. Not all of them are going to have that problem, but there might be a few blood cells trying to get down this blood vessel, and it just slows the process down. So that just only amplifies the problem. Not only are they not getting enough oxygen because of the shape, but now you're slowing it down to get to your vital areas. So how would someone know that they might have this sickle cell anemia? How would you know? You would go, yeah. You mean if you're going to harvest your bone marrow? That is extremely painful. Yep. Do what? No, that, if I'm thinking, you said the word that starts with a V, right? I thought you said vaccinated. No? Oh, okay. So then, no. But what you might do is go see this type of counselor. Not a speech counselor, not a school counselor, but let's say someone years down the road. Some of you are going to go on to be mothers, fathers, aunts, uncles, and all that, but usually the mothers and fathers. Why would someone see maybe a gene counselor? Well, it's not that they have terrible genes, but there could be such a possibility that someone can have that and be a carrier, okay? They're not affected by the disorder, but they have the ability to pass that on to their children. Because if the right possibility takes place, that can happen. So what I mean by that is, okay, as follows. I'll even make it make it color coding here. I need to grab two more. Okay, blue and okay. Remember doing Punnett squares in middle school? Okay, so I'm color coding this. That box is all black. So in this case, I'm going to put a capital B there and a capital B there. And then I'm going to put a lowercase b here and a lowercase b here. Okay? So what happens is these two individuals, somewhere on one of their 23 chromosomes, this is their genetic material. They decided to get married or whatever, or start a family. And then when we look at this genetic outcome that occurs, okay, oops, I need this letter here, and okay. Dad here has brown eyes. Mom here has brown eyes. But the significance in the color coding, what does that mean, do you think? 1 out of 4, which is what percentage? So if there's 4 quarters in a dollar, if you have 1 quarter, 25% of the time, there's a possibility that their offspring could have blue eyes. So brothers and sisters can have brown eyes, brown eyes, brown eyes, brown eyes, all of a sudden blue eyes. Or maybe blue eyes and blue eyes and blue eyes and brown eyes. Okay? It's not always going to be 75% of the time and 25% of the time that it's going to be blue eyes, but that's what statistically speaking could happen. In other words, the last thing we're going to talk about is this. Oh, hallelujah, you're saying. Okay? And that is, let's see, your vocab quiz tomorrow, and we'll have our exam next week. But if you had a coin, okay, what are your possible outcomes? It is. So statistically or mathematically speaking, if you do that 10 times, the math should tell you it should be 5 heads, 5 tails. Is that going to happen? It might, but probably not. So now if you flip a coin 100 times, it's probably not going to be 50 heads and 50 tails. You might get 65 and 35. Okay? The bigger data pool you take, the more the percentages are going to reflect this probably. It's just like, yeah, you might flip a coin, you might get tails 10 times. It's not likely, but it is possible. So that's what we mean by some of these mutations. There's just that possibility that it could happen. It doesn't mean that it will, it just means that it can. Okay, so I think that is enough for today. That's about 20 minutes of material. Vocab, I'm looking through you. Vocab quiz tomorrow. We'll review on Monday, and then we'll get started on our next unit on chromosomes and genetics. But that's when our Tiger project, it's part of next chapter as well. It's just a 2-year study, no, 4-year study on a couple of tigers and how they actually can possibly make it in the wild on their own if they're born in a zoo. Okay? The reason I say that is try to make sense of this. When we talk about pet cats, okay, people choose to do this, but it's the worst thing that you might be able, it's the worst thing to do to a cat if they spend time outside. Okay? And when we say take their claws out, why is that a potential problem? They can't really grip on anything. They really can't defend themselves. Okay? So that's what we mean. In a zoo, an animal doesn't have to worry about being fed. Okay? But then when you're out on your own in the wild, you either better be able to feed yourself to have the proper amount of nutrition, or you're just not going to make it. And not only is that animal not going to make it, it's not going to have that ability to pass off its traits to the next generation. Okay, so that's what we have coming up. We will catch up to you next time.